Alright, this video is meant to kind of advance our understanding of the linear combination or elimination method of solving systems of linear equations. You'll notice we have a system up at the top. 3x plus 2y equals 8. And also the equation 4y equals positive 24 minus 10x. The first thing we need to do in order to solve a system by elimination is to sort of line up our like terms. We want to get our x's and y's on the same side lined up in columns, and we want to get our constants on the right side or sort of other side. We want to get into standard form. So our first equation looks really good, but our second equation we need to move that 10x over to the left side. So again, the first thing that I'm going to do is add 10x to the right in order to get that 24 all by itself. And on the left side, we're going to add 10x to 4y. So now we've got our x's, our y's, and our constants all lined up. Now the step that makes this sort of the larger method of elimination, or the more sort of difficult method, is you'll notice that the 3 and the 10 aren't opposites. So if I added right now 13x is what I would get for a result. Oops, sorry, I got a little ahead of ourselves there. 13x is what I would have as a result. Then, in that same case, I would add the y's. Well, hey, 2y plus 4y is 6y. Also, I'm not going to eliminate. The idea of the elimination method is when adding the two equations, one of our variables should disappear. So, in order to eliminate when we add, we need to adjust our numbers. Now, turning 3 into 10 and 10 into the same thing, sorry, get a little ahead of ourselves again. 3 and 10 into the same thing is not a bad idea. We multiply and make them both into 30, but I think it's much easier to change 2 into 4. So why don't we take the top equation? If I multiply that by 2, we would have equal coefficients. If I multiply it by negative 2, though, then I'd have the opposite value of the other y value. So I'm going to have that negative 4y and a positive 4y. So now let's show that equation. Let's make that top equation multiplied by negative 2, because as long as we do both sides here, we're using that property of equality. I'm going to distribute negative 2 into both parts, and negative 6x minus 4y is equal to negative 16 on the right side. Then we keep our second equation as is, and now if we add those two equations together, you'll notice that negative 6x plus 10x is 4x. Negative 4y plus 4y is 0. Our y's have disappeared. And negative 16 plus 24 is 8. By dividing by 4, we get x equals 2. And then by simple substitution, now that I know what x is, we can plug that 2 back into our other equation, either into the top equation or the second equation. I went with the top one. 3 times x, which we now know is equal to 2, plus 2y equals 8. 3 times 2 is 6. We'll subtract that to the right side to get 2, and divide by that 2 to make y equals 1. And we now have the solution, x equals 2 when y equals 1. You can take those two numbers, plug them back into both of your original equations, and check your answer. Always a good idea. But overall, realize that the answer we've come up with is 2, 1. That would be the point, again, where these two equations, if we graph them in some way, shape, or form, that's the point where those two lines would cross. So let's take a look at another example of linear combination and how we can make this work. Taking a good look at our equations up here, we've got a 6x and a 4x, we've got a y and a 2y, and again our 37 and our 18. We're sort of lined up. Our x's, y's, and constants are all on the correct sides. 6 and 4, again, aren't hard to work with. We could make them both into 12, but again, much easier to manipulate this 1y. If we have a 2y here, I'd much rather have this be a negative 2y. So what I'm going to do is take equation A, or that first equation, right, up here, and I'm going to multiply it by negative 2. So this is going to be a negative 6 times 2 is negative 12x. Negative 2 times 1 is negative 2y. And negative 2 times 37 would be negative 74 over on the other side of the equal sign, right? Don't forget your equal sign. In that case, I'm just going to keep equation B sort of as is. I'm not going to change a thing. So 4x plus 2y equals 18. Add your equations together, it becomes a negative 8x. Our y's are going to cancel. Negative 2 plus 2 is 0. And negative 74 plus 18 would be a negative 56. Divide by negative 8. And you'll find out that x equals 7. Once we know that x equals 7, that's half of our answer. We can plug that back in again to one of my equations. So 4 times 7 plus 2y equals 18, which means 28 plus 2y equals 18. Subtract that 28. Divide by 2 on both sides, and y equals negative 5. Again, that's a great way to solve a system. Fairly quick and simple. The key is, again, lining up those variables, making sure that our negative 2 and our positive 2y up here disappear or eliminate in order to solve for that first variable. I hope that helps you solve systems by elimination. I'm thinking that maybe we can look at one more example if we have time here. So let's take a look at this one here. Now this one's a little more difficult. Our variables are lined up, but our coefficients don't line up as well. 3 and 4 and 5 and 2, right? When I'm thinking about those x's, I could make both of those coefficients into a 12. Or on the y's, I could make them both into a 10, but I'm not going to be able to just change one variable without using, maybe a decimal or a fraction. I'm thinking we can make it a little more simple, though, if we multiply by whole numbers. So let's take our top equation. Why don't we go ahead and eliminate the x values? So again, if I want to turn 3 into 12, I'm going to have to multiply that by 4. So again, if I call this equation A and this equation B, we could call this equation 4A. This can be a 12x, right? 4 times 3. Also, 4 times 5 would be a 20y. And 4 times 6 equals 24. At the same time, well, if this is 12x, I would love the bottom equation to have a negative 12x, in which case I'm going to have to multiply it by 3. So let's say 3b. 3 times negative 4 would be negative 12. 3 times 2 is 6. And 3 times our 5 is our 15. I'm going to pause the video now. Go ahead and add those two equations together. Solve for y. Plug it back in and see if you can't find the entire coordinate. When you restart the video, the solution will be on the screen. Go ahead and pause now. Okay, continuing now, you'll notice that again I added those two equations that we had together, which basically means our x is eliminated again. 12x plus negative 12x, again, is going to turn into 0. These two are going to eliminate. 20 plus 6 makes 26y. And again, 24 plus 15 was 39. When we divide by 26, 39 over 26 essentially is about 1.5. It's 1.5. Take that number, plug it back into our second equation here. Could have plugged it into the first one. It should work in both. But I'm going to plug 1.5 in times 2 here. Becomes a 3. Subtract our 3 to the other side. Divide by negative 4. And hopefully you ended up with x equals negative 0.5. Our overall answer again, the coordinate where both equations are true. I hope that helps you solve systems by elimination, even when the variables don't line up quite so well, when it's a little bit trickier. But again, still a very, very good method. If you have any other further questions, make sure you talk to your math teacher. Otherwise, good luck, and as always, have fun.